All right, so for today, we're going to be looking at graphing, graphing fractions, rational expressions, or rational equations this case. First of all, simplify as much as you can. Factor things out. The negative sign, I'm going to give it to the top. So I have a negative 1 over x plus 4. Factor anything that we can because we're going to be able to find some holes. These are points where the graph doesn't exist. We're going to find a vertical asymptote. And we're going to find a horizontal asymptote. All right. If I'm able to factor things out and things cancel out, that's going to give me a hole. In this case, none of them. I'm not able to get a hole. Now, my vertical asymptote, I look at the bottom of the equation. So I'm looking at x plus 4. And I'm start thinking, what values of x make the bottom equal to 0? I have x plus 4. The value of x that's going to make the bottom equal to 0 will be x equals negative 4. Now for the horizontal asymptote, the exponents what comes into place. I look at the highest exponent of x. And I ask myself, where is the highest exponent? The top, the bottom, or probably the same. When the biggest exponent is at the bottom, like in this case, my horizontal asymptote is y equals 0. We're going to see today all three cases. Right? The highest exponent is at the bottom, the highest exponent is at the top, or what if the highest exponent is in both? All right, so looking at our asymptotes, my vertical asymptote is x equals negative 4. So I'm going to draw the line x equals negative 4. Notice not just a straight line, it's a dotted line. Now that's the line where my graph is going to get close to it, it's just not going to cross it. My horizontal asymptote in this case is the line y equals 0. I don't have any holes, so I don't have to worry about that. Now, when I look on the left of my vertical asymptote, I have two sections. Well, as a matter of fact, overall I have 4 sections, but to the left of my vertical asymptote, I have those 2 sections. My graph is in one of them. Remember, it has to get close to the asymptotes, just not touch it or not cross it, but it has to get close to it, and it's on one of those 2 sections. The way I'm going to find out, I'm going to choose a value of x to the left of my asymptote. Let me choose, I'm not going to do negative 5 because the point of negative 5 is an easy point. Let me do something like negative 6. I just want to know in which section is that point. So if I do negative 6, right, any point to the left of negative 4. So I have, my equation is negative 1 over x plus 4. Since I said x equals negative 6, I have negative 1 over negative 6 plus 4, or negative 1 over negative 2. So that gives me 1/2. Once again, I'm just interested, that point, if I graph it, is here. That point is in that area. So I know my graph is in that area. Remember I said it's going to get close to the asymptotes, not cross it, but close to them. I know it's in this area in the top, so I'm just going to say there. And there. Now, to the right of my asymptote, it's either in this section or this section. I'm going to choose a value of x to the right of my asymptote. So in this case, let me choose -3. I have my equation -1 over x plus 4. So -1 over -3 plus 4. -1 over 1. That point is... So that tells me that my graph is in this section. So my graph is going to look like that. Don't think that the graph, part of it has to be above the horizontal asymptote and the other half below the asymptote, because it could be both parts of my graph below or both parts above. All right, so remember, I'm looking for a hole. In this case, I didn't have any. We're going to see those. Looking for a vertical asymptote, and I'm looking for a horizontal asymptote. Let's take a look at number 6. I'm going to start factoring first. So I take the -x out. So that gives me x squared minus 4x plus 3. I take the negative sign out just because it's a little bit easier to work with. Now I have a -x. And then x squared minus 4x plus 3, I'm going to factor that. That's going to give me x minus 3, x minus 1. Factor using synthetic division or factor using the x thing we used to do. Now looking at the bottom, I'm going to factor an x. So that's going to give me x squared minus 1. So I have the x from the front. Now x squared minus 1, I'm going to factor that as x plus 1, x minus 1. Now in this case, I do have things that cancel out. The x minus 1 and the x. So what I have left over, I have the negative right there. Have a negative sign, and then x minus 3 over x plus 1. All right, so I'm looking for holes. I'm looking for vertical asymptote first. Okay, so now vertical asymptote, let me abbreviate that as vertical asymptote and horizontal asymptote. All right, now I get a hole if things cancel out, if some factors were able to cancel out. Now when I look at the first one, that factor canceled out, and I ask myself, what value of x will make those parentheses equal to 0? So x equals 0. That is one of my holes. I need to find the y value of that. Have another hole here, and I ask myself, what value of x will make that parentheses equal to 0? So the x value is 1. I need to figure out the y value. Now to find the y value, I'm going to use the remaining function, the remaining equation here. So I said, well, if x equals 0, I have negative over 0 minus 3 over 0 plus 1. So I have that the y value is 3. Okay, so I plug that in here. Then I said, well, what if x equals 1? Once again, I'm using the remaining expression, so I have a negative sign. If x equals 1, I have 1 minus 3 over 1 plus 1. And I end up finding that y is equal to 1. Okay, so that gives me two holes. Remember, if things are able to cancel out, I get holes. Now, my vertical asymptote, I'm looking at the bottom of my expression. So I'm looking at x plus 1. And I ask myself, what value of x will make that equal to 0? So my vertical asymptote is going to be at x equals negative 1. Now for my horizontal asymptote, I look at the very beginning. I look at my highest exponents. My highest exponents are equal. Right? If the highest exponent was bigger at the bottom, my horizontal asymptote is equal to y equal to 0. Because they are equal, I'm going to look at the numbers in front of the x to the third. So I have a negative 1 and I have a positive 1. So I'm just going to go negative 1 divided by positive 1. So my horizontal asymptote is y equals negative 1. When the exponents are equal, divide the leading coefficients. The very numbers at the very front. Negative 1 divided by 1 gave me negative 1. All right, let me graph my asymptotes first. X equals negative 1. It's that one. Y equals negative 1 is that. Now, when I look at the left of my asymptote, I get that section or this section. Then on the right of my asymptote, let me change it to green. I either have this section or this section. All right, let's take a look at my holes as well. Have the point 0, 3. And I have the point 1, 1. Okay, now let's take a look at the left of my asymptote. I need to know from those two yellow sections, I'm going to choose a value of x that is to the left of negative 1. So in this case, let me choose negative 2. And I'm going to be using this equation right here. So I'm choosing x equals negative 2. Remember, I chose something to the left of my asymptote. I just chose the negative 2. So I have my equation is negative x minus 3 over x plus 1. So I have a negative sign, negative 2 minus 3 over negative 2 plus 1. Have a negative of a negative 5 over negative 1. So I have 5 over negative 1. So that gives me negative 5. So I have the point negative 2, negative 5 is on my graph. So from my yellow sections, I know I don't have it on this section. I have it at the bottom. So my graph is going to look like that. Now, on the green sections, it's in one of them. But in this case, I can find a value of x and see what I get. Now, the values of x is the holes in this case are going to help me because the holes are in this section. I know the graph is in this section. So my graph is going to look like this. It skips that point, skips that point. So that's my graph. Now on your homework, on your choices for your homework, it's not easy to do the hole. So it's going to look like it's a complete circle. Technically it's an open circle, but because of the size, it looks like a whole circle. So that's how it's going to look like. All right, let's take a look at number 7. First, let me factor things out. Looking on the top, let me factor an x. So it's going to give me x squared minus 5x plus 4. So I'm going to have an x. Now, x squared minus 5x plus 4, let me factor that as x minus 1, x minus 4. Now, let's take a look at the bottom. I'm going to factor a 3. So it's going to give me x squared minus 7x plus 12. So I have the 3 on the outside. Let me factor that as x minus 3, x minus 4. I notice the x minus 4s cancel out, so it's going to give me a whole. So I'm looking for wholes, vertical asymptote. I'm looking for horizontal asymptote. All right, I have a whole where x equals 4. Now, to find the y value, looking at what I have left over, I have a 4, right, because I'm saying x equals 4. 4 times 3 over 3 times 1. Notice I replaced the value of 4 for x. Now 4 times 3 over 3 times 1. I get that the y value is 4. So I have a whole of 4, 4. My vertical asymptote, I'm looking at the bottom of my fraction. I'm looking at what values of x could make the bottom equal to 0. My vertical asymptote is at x equals 3. Now for my horizontal asymptote, when my highest exponent is on top, have to do long division. I'm going to have a slanted asymptote. So I'm just going to go 3x squared minus 21x plus 36. I'm going to divide this into x to the third minus 5x squared plus 4x. Remember, from long division, I look at the first term divided by the first term. So I'm literally going to go x to the third divided by 3x to the second. That gives me x over 3. So I'm literally going to write this as 1/3 x. Notice I took the x out of the fraction. This is 1 over 3x. Okay, so let me distribute the 1/3. Numbers wise, 3 times 1/3 is 1. X squared times x, I get 1x to the third. Now here, negative 21 times 1/3, that gives me negative 7 x squared. 36 times 1/3, that gives me plus 12x. Remember long division, I draw the line, change the signs. So this is minus, this is plus, this is minus. First term cancels out. So it's going to give me 2x squared minus 8x. Looking at the leading coefficient, leading terms, I'm looking at 2x squared divided by 3x squared. The x squares cancel out, so I get plus 2/3. Once I get a numbered, even if it's a fraction, once I get a numbered without an x, I don't have to finish my long division. I'm going to say my horizontal asymptote is going to be 1/3 x plus 2/3. Going to be a little slanted. That line is a little slanted. All right, so let's take a look. Let's graph these. My vertical asymptote is at x equals 3. My horizontal asymptote is at the line 1/3 x plus 2/3. Remember how I used to write the line y equals mx plus b? I'm going to begin at 2/3, 2/3 is about here. My slope is 1/3. So let me go up 1 over 3. So that gives me the line like this. So my line's a little slanted. I have a hole, a 4, 4. All right, let's take a look. To the left of my asymptote, I'm in this section or this section. To the right of my asymptote, I'm in this section or this section. All right, to find out to the left of my asymptote, let me erase this first. Let me give myself some room. All right, so to find to the left of it, I'm going to choose a value less than 3. And the equation that I'm using, the expression where I'm going to plug in my value is x minus 1 over 3 x minus 3. Basically this, what I have left over after I cancel that x minus 4. So I'm thinking any value less than 3. I don't know, let's try the point 2. Well, what if x equals 2? So I have 2 times 1 over 3 times negative 1. Gives me the value of negative 2/3. So that tells me that it's in this section. So now that I know it's in this section, I'm just going to say I get this. Now in the green sections, either the one on the top or the one on the bottom, I see the hole is on the top. So that just tells me my graph is on that section. So that's what I get. Let me go over the horizontal asymptotes real quick. I'll do number 8 in a minute. But going back on number 6, the horizontal asymptote, the highest exponent was at the bottom, so y equals 0. When the highest exponents top and bottom, we divide the leading numbers, the leading coefficients. Now, when the highest exponent is on the top, we have to do long division. All right, let's take a look at number 8. Let me factor if I can. It's already factored, nothing cancels out. So I have the equation x plus 4 and x plus 1. I'm looking to see if I have any holes, any vertical asymptote, any horizontal asymptote. Now, because nothing cancels out, I don't have a hole. My vertical asymptote, I'm looking at the bottom. And I'm asking, what values of x make the bottom equal to 0? Now, for the horizontal asymptote, I look at the highest exponents. The highest exponents top and the bottom. So I'm going to look at the numbers right in front of the x. Technically, it's a 1 over 1. And I'm going to divide that. 1 over 1. So my horizontal asymptote is y equals 1. Right? 1 divided by 1 is 1. So now that I know my asymptotes, let's look at the line x equals negative 1. Let's look at the line y equals 1. Now, to the left of my asymptote, I'm either in this section or this section. To the right of the asymptote, I'm either on this section or this section. So let's take a look at the yellow sections. I'm going to choose a value of x less than -1. So to the left of -1, let me choose -2. Remember my expression is x plus 4 over x plus 1. I was not able to factor anything. So if x equals -2, I have -2 plus 4, -2 plus 1. So that gives me the y value is -2. So I have the point -2, -2. It's a point. It is in this section. So I know which of the two sections it is. So I'm going to say my graph looks like that. Now let's take a look at the green sections. Once again, my graph could be both below the horizontal asymptote. Let's take a look. I'm going to choose a value to the right of -1. A value that is easy to work with is x equals 0. Remember my equation, I have x plus 4, x plus 1. So I'm saying x equals 0. I have 4 over 1. So I have the point 0, 4. All right, so I know my graph is in that section. So there.